Hello, Assalamualaikum. My name is Zafran and my partner name is KAMAL. And today I want to show you about a voltage regulator. As you can see here, this is a series voltage regulator. It consists 4 stages. The first stage is the sampling unit. The output voltage are compared with reference voltage in the error detector stage. And the error signal is sent to the control element which controls the output voltage. Reference voltage are used in the second stage. For the comparison, this stage supplies reference voltage to the error detector stage. The control element is the third stage. The series voltage regulator, control element, and amplifier signal are used to keep the output voltage constant. The final stage is the error detector. Okay, now I want to run the simulation of the circuit. As you can see here, the V input is 15 volt and we have to get V out 15 volt, and then we run. As you can see here, this is our V output. We get 15 volt as the calculation, and then we change the value to 20 volt, and then we run the simulation. We also get 15 volt, and then we stop the simulation and we change the input to 25 volt, and we run. We still get a 15 volt output. Okay, as you can see here, this is the design tool for our lab. This is shunt voltage regulator. The shunt voltage regulator is controlling element in a series voltage regulator is connected in series, whether the transistor in a shunt voltage regulator is connected in parallel. The reference voltage is applied to the inverting amp input, and the sampling unit output is applied to the non-inverting amp input. Okay, so we run the simulation. As you can see here, is 4.955 volt, is approximate to 5 volt, and the V out V1 is 5 volt, so it close to the number, to the value. Okay, and then we change the value of the V input to 10 volt, and then we run the simulation. We get 5 volt also. Okay, and then we change the value to 15 volt. Okay, and then we run the simulation. We also get 5 volt output. Okay, and this is our design tree for our lab. For this design, we use 3 terminal pin, that is input pin, output pin, and adjustment pin. The LM117 circuit diagram is a typical configuration of the LM117 voltage regulator circuit diagram, which includes the decoupling capacitors. This is the capacitor. This LM117 circuit can provide variable DC power supply with an output of 1 ampere and an adjustment range up to 30 volt. A low side resistor and a high side resistor are connected in series to form a resistive voltage divider, which is a passive linear circuit that produces an output voltage that is a fraction of its input voltage. Okay, this is our function generator, and this 13 is our V input. And then we run the simulation. As you can see here, we get 12.4 volt, and the value is changing, and our calculation show that we have to get 12 volt. Okay, and then we change the value to 18, and then we run the simulation. Yeah, we still get 12 volt for our voltage output, and we change the value to 24 volt, and then we run the simulation, and we still get 12 volt, but the value at the decimal point is increasing. You see here. And that's all from us for this lab 3. Thank you.